Ever catch yourself like thinking about absolute zero? You know, that whole idea of everything freezing solid, even atoms just stopping. It's kind of wild. But today, we're really diving into that kind of cold, the science of the extremes. And get this, the absolute coldest spots. They aren't just, like, theoretical. We're talking real places. And for this deep dive, we've got exploring the coldest place in the universe, an epic journey through space and time as our guide. So bundle up, folks. This is going to be a chilly one.
Yeah, you might say that. We're talking temperatures that make a winter on Earth feel like a summer vacation.
No kidding. Okay, so before we turn into popsicles ourselves, let's start with something that really threw me for a loop in this article, the Boomerang Nebula, about 5,000 light years away. This thing isn't just cold, it's colder than the background temperature of space itself. How does that even work? I thought space was like the ultimate freezer.
It's a good question, and it shows how much we keep learning about space, you know? See, the Boomerang Nebula is what we call a planetary nebula. Basically, it's the leftovers of a dying star. So picture this. A star way bigger than our sun, running out of fuel and puffing out its outer layers. Gas, dust, all that stuff. That's what we see as the nebula.
Okay, I get the visual, but why so incredibly cold?
It's all about how much particles are moving, their energy. The slower they move, the less energy they got, the colder things get. Temperature, you see, it's really about kinetic energy. And in the Boomerang Nebula, those gas and dust particles, they're barely moving. We're talking just 1 degree Kelvin.
1 degree Kelvin. Okay, for those of us who don't speak super science, how cold, I ask that?
Right, think of it this way. 1 degree Kelvin is about negative 459.67 degrees Fahrenheit. Space, even the emptiest parts, are usually around negative 454. So yeah, this nebula, it's a few degrees colder than empty space.
That's crazy, like finding an ice cube in a volcano almost. But there's got to be more to it than just, wow, that's cold, right? Why do scientists even care about this super chilled nebula?
Oh, absolutely. See, studying these dying stars, especially ones as extreme as the Boomerang Nebula, it gives astronomers clues about how stars in general live and die, like a cosmic diary or something.
So one super cold spot is telling us about something huge, like the whole life cycle of stars. That's amazing. But something tells me that's not the only chilly wonder out there. What else is hanging out in the cold depths of space?
Well, you mentioned space's background temperature, which is pretty amazing by itself. That chill, about negative 270 degrees Celsius, that's negative 454 Fahrenheit, that's actually like leftover heat from the Big Bang. The universe's afterglow, you could say. It's everywhere.
Wow, so even in the farthest reaches of space, we're still feeling the Big Bang. That's mind-blowing. But let's bring it a little closer to home. Got to be some cold contenders in our own solar system, right?
Yeah, definitely. And the coldest one might surprise you. It's Uranus. Yeah, the one that's kind of tipped over on its side. It's got the coldest atmosphere we know of, negative 224 Celsius or negative 371 Fahrenheit. Colder than Neptune, even though Neptune's farther out.
Hold on, how's that work? I always figure the further from the sun, the colder things get.
Common thought, but it's not always that simple. Distance matters, yeah, but with Uranus, it's that tilt. It means parts of the planet are in sunlight for decades, then darkness for decades. Makes for some seriously weird and cold weather.
So like seasons, but on a whole other level.
Exactly. And while we're talking about surprising chills, gotta mention Neptune's moon, Triton. That one takes the cake for the coldest moon in our cosmic neighborhood. Brutal.
Man, we've got a regular coldest place competition going on, but let's bring it all the way back down to Earth. Where's the most extreme cold naturally happening here?
Antarctica, of course. But we're not just talking any ice and snow. The East Antarctic ice sheet, that's where it's at. This place is like a frozen desert. They hit a record low back in 2010, negative 92.3 Celsius. That's negative 134 Fahrenheit.
Whoa, even colder than what they had at the Vostok station, and that record stood forever.
Right. It's amazing what you find in those conditions. The altitude, the wind, it all plays a part. It's so harsh. Even surviving there is incredibly difficult.
Makes you wonder if anything can live in that.
Yeah.
Besides, like, penguins, I guess.
You'd be amazed. Even there, life finds a way. Microorganisms, tiny bacteria, algae, they figure out how to survive. Adapted to the cold, the lack of light, the whole deal. It's remarkable.
Life is tough. But even with those little survivors, doing research there must be incredibly hard.
Oh, for sure. That's why they built places like the Dome Fuji Station. Designed to handle the cold, keep people safe while they study. Human curiosity, you know, it finds a way.
I love that. Okay, but why go through all that? What can we learn from places this cold here or in space? What's a point of studying these frozen wastelands, basically?
You're hitting on something important. It's not just about breaking cold records. These places, they hold secrets. Secrets about our planet, the universe, all of it.
How so? What can we get from, like, a bunch of ice and snow?
Take that East Antarctic ice sheet. Did you know they drilled down and got ice cores? Those cores, they're like time capsules, going back 720,000 years.
Wait, so it's like looking back in time, but with ice instead of the time machine.
Exactly. Those cores trapped air bubbles as they formed, so we can analyze them, see what the atmosphere was like way back then, tells us about past climate change, maybe even helps us predict the future. Pretty important stuff.
So we're not just talking, brr, it's cold, we're talking time travel. That's wild. But get this, the article said the absolute coldest thing on Earth isn't even in Antarctica. It's in a lab.
Yeah. Scientists, they're good at recreating extreme environments, and that includes the cold ones.
Okay, hold up. Colder than the coldest place. How do you even do that?
It's about messing with matter on a tiny level. They've figured out how to make these clouds of gas, and then they cool them down to a fraction of a degree above absolute zero.
Clouds of gas. How do you even make a cloud stand still, let alone get that cold?
Not your average rain cloud. These are different. We're talking about atoms, usually stuff like rubidium, and they trap them, slow them way down using lasers and magnets.
Okay, now you're just showing off. Lasers, magnets, atom clouds? Is this even real life anymore?
It is, and it's called laser cooling. Totally changed how we study matter at these crazy temperatures.
But why go through all that? Just to make something cold? What's the point of studying stuff that cold anyway?
This is where it gets really cool. See, when you get things that cold, matter starts acting weird. Like, have you heard of superfluidity?
Superfluidity. Sounds familiar, but I can't quite place it.
It's not an everyday thing, that's for sure. Basically, a fluid, like liquid helium, it loses all resistance. It can flow without slowing down, even climb up walls.
Okay, now that sounds like science fiction. Liquids climbing walls. Come on.
Well, it's not that far off, and there's more. Superconductivity, that's another one. Electricity flowing with zero resistance. And we might even find totally new forms of matter.
New matter. You're killing me here. But
Yeah.
seriously, this is fascinating stuff. So by looking at the coldest spots, the nebulas, the labs, it's not just about saying, wow, cold. It's about what we learn about, well, everything.
It really changes how you see things, right? The universe is full of surprises and often the most extreme conditions. They teach us the most.
Makes you wonder what else is out there. What else haven't we found yet in these freezing corners of the universe?
Well, that'd be a whole other deep dive.
Maybe someday. But for now, that about wraps up our look at the coldest places and things out there. Thanks for braving the chill with us. Okay, so we've gone from, like, giant space clouds to some lab that fits in a building. It's wild to think we can make things here on Earth colder than anywhere else we know of. But before we get too far, you said these crazy low temps, they make matter act all weird. What's the deal with that? What's actually going on down there near absolute zero?
Think of it like this. You got atoms, right? Normally they're bouncing around, tons of energy. But cool them down, way down. It's like they chill out.
Yeah.
Barely moving, barely even bumping into each other. That's what we're getting at with these temperatures.
So it's like the atoms are just taking a break from, like, existing normally?
Kinda. And when they do that, weird stuff happens. They lose their individual, like, atomness almost, become this unified thing. That's where you get superfluidity, where liquids flow without slowing down, or superconductivity, where electricity does the same. It's wild.
So it's not just about being cold, it's about new rules for how things behave. That's incredible. Almost like a different kind of physics takes over.
You got it. Scientists, they can use these conditions to study the laws of physics in a way you just can't do normally, like finding a secret cheat code for the universe or something.
Okay, now I'm really seeing why this is so cool.
Yeah.
But what about those tech advances you mentioned? How does any of this turn into something we can actually use from these super cold discoveries?
Well, take superconductivity. Imagine if we could transmit electricity with zero energy loss. Power grids, transportation, computers. It'd be revolutionary.
No more wasted power, no more things overheating. Sign me up.
Exactly. And there's more. Quantum computing, that relies on some of these same crazy quantum effects that happen at these temperatures. It could be huge.
Quantum computing. See, now that's another deep dive entirely. But I get it. We're not just finding cold stuff, we're finding ways to use it that could change everything.
And the best part, we're just getting started. Every new experiment, every time we learn something new about these temperatures, it's like more doors open up, more possibilities.
Like exploring a whole new world, except this world is like frozen solid. So as we wrap up thinking about these crazy cold places, the space stuff, the labs, what's the one big thing you want people to walk away with?
I think for me, the biggest thing is it's not just about the cold itself, you know? It's not like, oh, empty space, that's cold. It's more like these places make us rethink everything, how
Hmm.
matter works, energy, even what's real, you know?
Totally. And what gets me is it's all driven by like pure curiosity.
Mhm.
Nobody's making us explore this stuff. It's because we have to know. We got to understand the universe, even the parts that seem impossible.
It's like that saying, right? Gotta see what's over the next hill. But in this case, the hill's absolute zero. And the view could change everything.
No kidding. Just imagine if we could actually feel those temperatures. Stand on Triton or be inside a cloud of atoms practically frozen solid.
Yeah.
Would it even be like our universe anymore? Okay, no, that's a scary thought. But that's what I love about these deep dives. It's not just the answers, it's the new questions they make you ask.
Right. And who knows, maybe someone listening right now, they're going to be the one to figure it all out. Find even colder places, new tech, the whole deal.
There you go, folks. A challenge from the expert. Go explore the universe's cold spots, why not?
Yeah.
But for us, we've reached the end of our look at the science of extreme cold. Huge thanks to our expert for, well, being an expert. It's been mind-blowing.
Happy to be here. Always fun to talk about this stuff.
And to everyone listening, thanks for braving the chill with us. Keep exploring, keep wondering, and we'll catch you on the next deep dive.